Digital systems can be created to perform many different tasks. A simple digital system is diagrammed here. This block diagram shows a series of steps that lead to an effective random display of a digital number. There is a clocking function, a counter, a decoder, a 7-segment LED display driver, and an LED display. When the push button is pressed or closed, a signal from the clock is sent to the counter. This signal starts a repeating up-counting sequence from 1 to 6. When the push button switch is opened, the counter will stop at a random number between 1 and 6. Because the counter cycles through digits so quickly, it's impossible to tell where it will stop. With this button push, it has stopped at 3. The binary output from the counter representing the number 3 is translated by the decoder into a 7-segment code, and the LED display driver lights the appropriate segments of the LED display. Here is a more realistic depiction of the rolling of a single die. Again, we have a clocking function and a counter. This simulation uses a logic block to decode the counter input and to drive the display of 7 LED lights that mimic the dot pattern on a die. Pressing or closing the push button switch causes the clock to generate a square wave signal. This signal activates the down counter to cycle through a repeating count of 6 through 1. When the push button is opened, the counter randomly stops on a number. The binary output from the counter is decoded by the logic block, which lights the proper LEDs representing the decimal value of the counter. Thus, each time the push button switch is pressed and released, a random number from 1 to 6 is generated and is displayed as one side of a 6-sided die.